Welcome you all for this section. Today we are going to discuss certain topics in kinematics of machinery. Okay, this is actually a continuation of your previous class. The previous class we discussed about the various course outcomes. Okay, and today we are going to discuss about certain topics in the first course outcome. That is one, we are applying the knowledge of fundamentals of kinematics to common mechanism and determine kinematic parameters of mechanism. So the previous class we had some introduction over what is meant by kinematics and dynamics. Today we are going to have some continuations over this. Okay, this was the syllabus for your unit 1, and so we had some basic concepts. Today let's start with this kinematic pair. So what is meant by a kinematic pair? A kinematic pair is, or simply a pair, you can even call it as a pair also. It's not that we have to call it as a kinematic pair. It can be called as a pair. Is a joint of two links, okay, having relative motion between them. It's not applicable when there is no relative motion between them. One motion should affect the other one. Okay, so that is the main criteria here. So the kinematic pair or simply a pair is a joint of two links having relative motion between them. You can see here the above given slider crank mechanism, link 2 will be rotating relative to link 1. Okay, and how it will be, you can see here link 2 will be rotating relative to your link 1 and will constitute a revolute or turning pair. Okay, similarly links 2, 3 and 3, 4 constitute turning pairs. So you see here how is 3, 4, it will be turning, isn't it? And you consider 2 and 3, it also be turning. Link 4, it's reciprocating. You can see this slider will be reciprocating with respect to the link 1, and it is called as a sliding pair. So okay, link 2 is you can see again I am saying link 2 and 1, it will be a revolving or it will be a turning one. 2 and 3, or it can be even 3 and 4, it can be turning pairs. Okay, so they will be turning, and the link 4 will be a reciprocating or it will be a sliding pair. Next one will be your classification of kinematic pair. So how we are going to classify it? There are certain criteria upon which we are going to determine the kinematic pairs. Okay, number 1 will be based on your type of contact. It will be a lower pair or higher pair. Right, then it can be about based on your type of constraint. It can be a closed pair or unclosed pair. So type of relative motion, it can be a sliding pair, a rolling pair, turning pair, screw pair and spherical pair. Okay, so these are the various classifications of kinematic pairs and we'll be discussing now. So next will be, you will have it as a type of contact. So I said based on the type of contact I'm having as two classifications. They are the lower pair and the higher pair. So what it is actually? Number 1 is lower pair. A pair of links having a link in, when you pair means they'll have relative motions between them. Say a pair of links having surface or area of contact between the members, it is called as lower pair. Okay, the contact surfaces will of the two links will be the similar. You can see here this surface area of these two will be the similar. For example, if a nut is turning on a screw, how it will be? The shaft is rotating on a bearing. The surface area, it will be the same. All pairs of slider crank mechanisms and universal joints, they will called as lower pairs. Okay, since they are having surface or area contact between the members. Okay, it's called as a lower pair. Next one is your higher pair. What it is higher pair? When a pair has point or line contact between the links, it's called as your higher pair. Okay, so the contact surfaces will be dissimilar. That what happens, you are having a bearing over the shaft. So what will happen? The outer diameter of the shaft will be completely, it will be in contact with the inner diameter of the bearing, like that. But here what it is, the contact surfaces of the two links are dissimilar. What can be the examples? The wheel rotating on a surface cam. Okay, on a surface cam and follower pair. Can you see this? It is of dissimilar. Okay, tooth gears, ball and roller bearings. These are some examples for higher pair. You have to you should be in a position to identify the difference between them. Next one, based on the types of constraint. So based on the types of constraint, we have it as closed pair. And what is meant by closed pair? When the elements of a pair are held together mechanically, we call it as a closed pair. The contact between the two can only be broken only by the destruction of at least one of the members. Normally, when you are having the surface area is in contact, they will be they'll be very joined together, and you can't dismantle them without breaking them. So normally, the lower pairs, all the lower pairs will be closed pairs only. They cannot be easily removed. So that will be one of the properties of closed pair. Okay. Next one is your unclosed pair. So what it is? What it is actually, unclosed pair is when the links of a kinematic pair are not held together mechanically. So that only I have given you in block. They are not held together mechanically. The pairs we call it as unclosed pair. And cam and follower pair is an example of unclosed pair because because the contacts with the two links, this is maintained by force of gravity. It can be the force of gravity of spring or anything else. Okay, they are not held together mechanically, but they are joining as a pair, and there is a relative motion between them. Okay, so this is a unclosed pair. And based on the types of relative motions, we can have it as sliding pair. What it is? When two links of a kinetic pair have a sliding motion relative to each other, they form a sliding pair. A rectangular rod in a rectangular hole as shown in figure is a sliding pair. Similarly, what it is actually, you can see that there's no rotation or anything else. Okay, that is called as a sliding pair. Next one will be a rolling pair. So how it is actually, when two links of a kinematic pair have a rolling motion related to each other, then we constitute a rolling pair. For example, you can see a ball is rolling in a ball bearing. You can see in the diagram figure. Okay, so this will have it as a rolling pair. Okay, you'll have outer rays and also inner rays, and the ball will be rolling between them. And based on the type of relative motions, again we have a turning pair. What it is? When one of the links of a kinematic pair has a turning or revolving motion related to the other, they form a turning pair, or it is also called as a revolving pair. A circular shaft rotating inside a bearing is an example of turning pair. Okay, so that is, we call it as a turning pair. Next one, what it is? Next one is your screw pair. Okay, well, this is based on the types of relative motions. Okay, what is meant by screw pair? Have a turning as well as sliding. So that is, see, whenever you are just moving your nut through your screw, what will happen actually? It will be rotating at the same time it will be moving axially also. Okay, so that is, it will have both turning as well as sliding motion. Then they constitute as a screw pair. Okay, nut and bolt pair will be an example. So how you can achieve this? By matching threads on the two links. The threads should be matched with respect to each other. Next one is your, okay, so we have it as a spherical pair. Okay, so next one we have it as a spherical pair. Okay, so how about a spherical pair? Can anyone say this? How it will be? Okay, so this spherical pair, when one of the links of a kinematic pair is in the form of a sphere and it turns inside the other fixed link, is called as a spherical pair. You can see here, okay, the ball and socket joint will be an example of your spherical pair. So thanks for watching. Okay, and we'll be meeting in the next section. Thank you all.